All right, to start chapter 8, we're going to go back to the Pythagorean Theorem, which you guys have known for a while. The Pythagorean Theorem is only used for right triangles, so you have to have a triangle that has the right angle box there. Now, parts of a right triangle. The sides that buddy up to your right angle, we call them sides A and B, are your legs, okay? There's no differentiation between the two, they're just both legs. And then the side across from your right angle, this one here, we call C, and is your hypotenuse, okay? So if you ever see the word hypotenuse, that means it's a right triangle. Remember hypotenuse leg from congruent triangles, all right? So one thing to know about your hypotenuse also is that it is always the longest side or the largest side. So always the largest side. And that will help you with a few of the problems we have below. So then, as you remember, right here is your Pythagorean theorem. A squared plus b squared equals c squared. So leg squared plus leg squared should equal your hypotenuse squared. So let's actually put that to use here. So find the length of the hypotenuse, and we're going to round to the nearest tenth. This box should actually be down here. Whoops. We don't need that, and this 3 actually should be right there, okay? All right, so let's go ahead and label this. We can call these sides A and B. It doesn't matter which one is A and which one is B. It just matters that this one over here is C, because that's your hypotenuse. So now when we go ahead and use our Pythagorean theorem, we would do 5 squared plus 3 squared equals C squared, and then we'll solve. So 5 squared is 25, 3 squared is 9, that's still equal to c squared. Now we will add, so 25 plus 9 is 34, and now this is where a lot of people think they are at their answer, but we do not have the value of c, we have c squared. To undo a square, we square root. So you need to do the square root of 34, and you'll get c is 5.8. All right? So make sure you always remember to square root at the end. All right, example number 2 is a little bit different because we're just going to find x, which is actually a leg here. So we can call this A and B, and then 14 is our C. So there should be a right angle box here. I think it got cut out. So we would go 7 squared plus x squared equals 14 squared. Okay? It always has to be equal to your hypotenuse. It doesn't matter what's missing. Just put what's missing in the spot it is supposed to go in. All right? So 7 squared is 49 plus x squared, and then 14 squared is 196. All right? Now we're just going to have to do a little bit of algebra here. So we'll subtract 49. So we're left with x squared on the left, and then 196 minus 49 is 147. And again, you are not done because we need to go ahead and square root so that we can find out that x is actually 12.1 since we're rounding to the tenths place, which is one spot after the decimal. All right, always make sure you have your rounding correct. If it's a fill-in-the-blank problem, you will have to have it rounded correctly to get it right. All right, now you have the converse of the Pythagorean theorem. This says, if a squared plus b squared equals c squared, then I can say it's a right triangle. So this triangle pictured right here with 8, 15, and 17, we do not know if it is a right triangle. I do know if it is, 17 is my longest side, so that has to be my hypotenuse, or c. So then my right angle box would go right here. So this has to be my C, and these can be my A and B. So then we just test it out. Is 8 squared plus 15 squared equal to 17 squared? All right? So what we can do, pull up our calculator, go ahead and type in 8 squared plus 15 squared, enter, and we get 289. Then we'll check 17 squared. And we also get 289. So, this was 289, this was 289. So yes, this is a right triangle. Let's try this last example. So again, 31 is the biggest, so this has to be my C, so my right angle would go here if it was a right triangle. So we'll do 20 squared plus 21 squared equals 31 squared. And we'll go ahead and check these in the calculator. So 20 squared plus 21 squared is 841. 31 squared is 961. Those are not equal. 841 is not equal to 961. So no, this is not a right triangle. All right, let's go on to the back. All right, so some other things we'll have with our Pythagorean theorem is you might have to decide if a set of 3 numbers is a Pythagorean triple. It's 3 whole numbers that work to make a right triangle. So they satisfy the equation being the Pythagorean theorem. Okay, so we can do these few examples to go ahead and see. So again, biggest one has to be your C. So we would go 8 squared plus 15 squared equals 16 squared, and see if that is true. 8 squared plus 15 squared is 289, but 16 squared is 256. So those are not equal. So is it a right triangle? No. And if it's not a right triangle, it cannot be a Pythagorean triple. All right. So this next one, 20 squared, 52 has to be our C, plus 48 squared equals 52 squared. All right? 20 squared plus 48 squared is 2,704. And 52 squared is 2,704. Those are equal. So, yes, it is a right triangle. Did we use all whole numbers? Yes, we did. So it is also a Pythagorean triple. Now, looking at this last one right here, 3/5 is going to be our biggest. You can always double check that in the calculator though. So we would have that squared plus the square root of 6 over 5 squared equal to 3/5 squared. Okay? So we'll go ahead and check if this is going to be a right triangle. So when you're squaring fractions, you can square the top and the bottom separately. Well, if I square a square root, it just goes away. So I'm left with just 3 on top, and 5 squared is 25. You can always do this in the calculator as well. The square root of 6 squared is 6. 5 squared is 25. And we're going to see if that is equal to 3 squared is 9. 5 squared is 25. Remember, when we add fractions, we just do the top. 3 plus 6 is 9. In the bottom, you have a common denominator. So this one, yes, this is a right triangle. But to be a Pythagorean triple, it has to be whole numbers, which these ones are not. So this is not a Pythagorean triple. All right, the last concept that you have to know with Pythagorean theorem is this. If c squared, so we already know if c squared is equal to a squared plus b squared, we have a right triangle. Well, if you have that c squared is greater than, so greater, then you have an obtuse triangle. So we can actually classify triangles as right, obtuse, or acute now. Because here, when c squared is less, then we have an acute triangle. And I'll show you how that works here with this example number 5. So, a triangle has side lengths 6, 11, and 14. 14 has to be our C because it's the biggest. So we'll go 6 squared plus 11 squared. We want that equal to 14 squared if we're using our Pythagorean theorem. When you do 6 squared plus 11 squared, you get 157. And when you do 14 squared, you get 196. 196 is bigger than 157, and this was your c squared, and over here was your a squared plus b squared. So if c squared was bigger, we have an obtuse triangle. If they're equal, it's right. If c squared is greater, it is obtuse. If c squared is less, it is acute. Okay? And then you can have an application problem, which really these ones are pretty easy if you draw a picture of the situation. So a roofer has a 16-foot ladder. He needs to reach the roof, which is 14 feet off the ground. Okay, so say you have this little house here, and he has to reach the roof right here, and we know that's going to be 14 feet off the ground, okay? So then you have the ground right here, and we know that a house is going to stand straight up with the ground, so it'll make a right angle. Now, you lean a ladder. That's always important to note. You lean a ladder. You don't put a ladder straight up and down, all right? So here would be your ladder, and that ladder is 16 feet, okay? It says it right here. A roofer has a 16-foot ladder. And it says, how far out from the house should the base of the ladder be? So here's the bottom of the ladder, and here's the house. So we're going to find that measure right there. So what we have is a Pythagorean Theorem problem. So across from our right angle has to be our hypotenuse. So that 16 is our hypotenuse. So 14 squared plus x squared equals 16 squared. And we'll solve. You can shortcut this a little bit and do, before you square, you can just subtract here. All right. So x squared is going to be equal to whatever 16 squared minus 14 squared is, which is 60. All right. And then we cannot forget we always need to square root. And it says round to the nearest tenths place, so we will call this 7.7 feet. All right, so go ahead and come in with these notes all filled in and make sure you have a good understanding of Pythagorean Theorem. See you in class.